Okay, this short video covers the use of transistors to form logic gates. So let me try to get this going. All right, so here's the kind of problem I'd like you to be able to do. Let's start with a logic gate. So here's a picture of a logic gate. And I'm going to want to fill out a truth table for this logic gate. So let's make this A and B, and then the output F. Okay, so consider zeros as low voltages and ones as high voltages. This would be the truth table. All right, so what we're trying to figure out is, based on this configuration of transistors, and remember in class we talked about transistors act like switches, what is this gate? Okay, so if we put 0, 0, let me change the color. If we put an input on the A gate of 0, 0, okay, so A is also tied to this point, so A is a 0, and B is tied to this point, so it's also a 0. So remember, if there's a bubble on the input of the gate, that switches on the transistor, so that acts like a switch, it closes. There's a bubble on the input, this transistor closes. These two, there's no bubble, so these two transistors are open. So there's no path. All right, let me change colors for path. There's no path to get from the output point F to ground. So F can't be a 0. All right, so let's undo that. Here's the path that can happen. F can go either this way to VDD or this way. There's a parallel way of getting it. Either way, it gets up to VDD, which is considered the high voltage, which is the same thing as a 1. All right, so for that particular input combination, that's a 1. Okay, let's do another. All right, so to do the other, let's clear what we had before. Okay, so in this case, we're going to have A equals 0 and B equal to 1. Yeah, we're doing this case. So A is a 0, B is a 1. All right, so look at the transistor configuration. Since that's a 0, it's an open. Since that's a 1, it's a short. Since this has a bubble on it, this is an open. This has a bubble on it, so the 0 means it's a short. So I look for the path. I have a path to VDD. I have a path all the way up to 1. I don't have a path down to 0. Okay, so we have yet another 1. Okay, you can work through the same logic with the other input combinations and you'll get 1 here. So let's do the last one just to make sure. I'm skipping the third one. Let's do the last one. All right, so in the last one, A is equal to 1 and B is equal to 1. We ask ourselves, what are the transistor configurations? Both these are zeros. Both these are 1s. Because there's a bubble there, this opens that circuit. It acts like a high impedance. All right, same thing here. These are both shorts because the 1 closes these transistors. So we ask ourselves, where is there a path to VDD or a path to ground? There's a path to ground in this case, and so the answer is that this would be a 0. All right, so if you go back to the basic gate video, you'll find that this acts like a NAND gate. Okay, this is the schematic for a NAND gate. All right, let's do one more. Let's consider this particular circuit configuration. All right, A and B with an output F, all the input combinations. Okay, so if we take A equals 0, B equals 0, what happens? Okay, well, what happens is, because these are bubbles, these are shorts, that's a bubble, that's a short on a 0. There's no bubble, so these are opens, and so there's a path to 1. Okay. All right, let's do the next combination. The next combination would be A equals 0, B equal 1. Okay. On that, this is an open. This is, I'm sorry, because there's a bubble there, and this is a 0. This is a short, but this one's an open because it's a 1. All right. This one's a 0 here, that means that's an open. There's a 1 here, which means that's a short. Okay, and so we look, what's the path? All right, so we know, we try to get to high and we run across an open circuit. Okay, so it can't be this one, and so we'll delete that. We look for a path. There's a path to ground, which is our 0. Okay. All right, so one last one. I think you'll see anytime any input's a 1, it's going to force the output to go to ground. So let's just try 2 1s, just to make sure we have this concept down. Okay, if A is a 1 and B is a 1, all right, both these would be open. So there's no path to high. Immediately we can see that. Here's a short, and hopefully you can see quickly that there's actually 2 paths to ground. So this would be a 0. Okay, so if you did A or B, that truth table would look like this. This is OR. So if you take the complement of that, this would be 1 0 0 0. So this is a NOR gate. Okay, so there's a short video on logic gates.